In this problem, we have a sled sliding down an inclined plane like shown in the picture. The incline angle alpha is given. There's friction between the sled and the inclined surface, and the coefficient of kinetic friction is given, mu sub k. The mass of the sled is also given, m, and we are told that the sled is accelerating down the incline, and we'd like to find out what the acceleration is equal to. So find an expression for acceleration in terms of the given variables. And what are those variables again? Mu sub k, alpha, m. And your answer may also include g, the gravitational acceleration, which is a physical constant, so it doesn't have to be given in a problem. We always know what g is, so g could be also part of our answer. Now, what am I going to do first? Well, there's an object that is accelerating. I want to find the acceleration, so let's actually apply Newton's laws, right? And what laws are those? Well, if there's acceleration, that's the second law. So along the direction of the incline, we're going to apply Newton's second law. And again, we're going to set up our force equation, and if there's an extra unknown that we want to get rid of, then we apply Newton's laws in the other direction, perpendicular to the incline angle, and in that direction there is no acceleration, there's not even motion, right? The entire motion is constrained to the inclined direction. So in the perpendicular direction, there is no motion, there is no acceleration. Net force is going to be equal to 0. So along the incline, net force equals mass times acceleration, Newton's second law. Perpendicular to the incline, net force equals 0, Newton's first law. But before I can apply any of those, what is it that I need to do? I need to draw a free body diagram, show all the forces acting on my sled, and then based on that, I'm going to come up with my force equations applying Newton's law. So first thing first, let's draw our free body diagram. Now, do I need to tilt my coordinate frame? Yes, absolutely. We have acceleration. We don't want to deal with x component or y component of the acceleration vector. We want the acceleration vector to follow one of the coordinate frame axes, and in this case we are going to select x-axis to be that direction. So I'm going to have my x-axis tilted such that it follows the direction of the incline, and obviously y-axis is going to be tilted as well. So the entire coordinate frame will be tilted such that down the incline is my positive x direction. Here's my free body diagram. I have gravitational force F sub g pointing directly down, always vertical. Even if your coordinate frame is rotated, Fg remains vertical. So then Fg is making an angle alpha with the negative y-axis as shown in the picture. I have also highlighted the x and y components of gravitation force Fg. The blue segment on the y-axis is the y component, and the green segment parallel to the x-axis is the x component of my gravitational force. So the x component is going to be Fg times sine alpha, and the y component is going to be negative Fg times cosine alpha. What other forces do I have? I have my normal force applied by the surface on the sled in the direction perpendicular to the surface. In other words, in the positive y direction. I also have my kinetic friction force pointing in the direction opposite the direction of motion. The sled is going down the incline. Kinetic friction is pointing up the incline. Also note the superscripts. Object, agent is the correct order. So the first letter is always S. It represents the sled. E represents the earth, that's for the gravitation force, and I represents the incline for normal force and kinetic friction force. Now that I have my free body diagram, what do I do next? I apply Newton's second law along the x-axis. Why? Because the acceleration is in the x direction, right? So the most natural next step will be to focus on the x direction and set up our force equation for the x direction. And I know that there's acceleration in the x direction, so that's Newton's second law. Net force equals mass times acceleration. Like so. So the general rule, always start with the general statement. Net force equals mass times acceleration. But be specific enough. We're talking about the x direction. Hence the superscript x in my net force expression, right? Net force in the x direction is equal to mass times acceleration. What do I do next? This is this is correct, this is nice, but this is not an equation that actually I can work on, right? I need to expand the left-hand side of my equation, the net force side of the equation, based on my free body diagram. So what are those forces in the x direction? I have kinetic friction, and then I have the x component of F sub g, right? Only those two forces are allowed to go into this force equation. F normal cannot go into this equation. Why? Because it doesn't have any x component, right? So F normal will have to wait for a little bit. If we focus on the y-axis and write down our force equation for the y-axis, then we will use F normal. But right now, no F normal, only FKF, kinetic friction, and FG, and the x component of FG. Here I have expanded the left-hand side of my equation. I have negative FKF plus FG sine alpha equals ma, mass times acceleration. Note the positive and negative signs because down the incline is my positive x direction. Kinetic friction force is negative and the x component of F sub g is positive. In the next step, I'm going to substitute the formulas for FKF and FG. These are not given variables, right? But I know that they have their formulas for these forces. FKF is equal to mu sub k times F normal. So that's good because mu sub k is a given variable. And then Fg, gravitational force, is equal to mass times gravitational acceleration. Fg equals m times g. So I'm going to substitute that as well in the next line. And here's what I get. Minus mu k F normal plus mg sine alpha equals ma. I also highlighted the given variables with different colors. Mu k is given, m is given, g is given like a known constant, physical constant, alpha is given. So is there anything that's not acceleration and that's not given? Yes, F normal is an unknown. So we're not done yet. We have to come up with an expression for F normal, and then we are going to isolate acceleration and solve for acceleration basically. So good news for F normal. Now we're going to focus on F normal. Look at the free body diagram. What is F normal doing? It's pointing in the positive y direction. So then let's focus on the y-axis. Set up our force equation for the y-axis, and which law from Newton am I using for that? Remember, along the y direction, there is no acceleration. So net force in the y direction equals 0. So a rule of thumb, always start with the general statement, net force in the y direction equals 0. Now we're going to go ahead and write down our specific force formula. We're going to expand the left-hand side based on our free body diagram. Which forces are allowed to go into this equation? Kinetic friction is not going into this equation because it doesn't have a y component. F normal will be included in this equation because it is pointing in the positive y direction. And F sub g also will be included in this equation because it has a y component. It's pointing in the negative y direction, right? And the y component is the segment that I highlighted with this blue color. What is it doing? It's adjacent to the angle alpha, so that's a cosine. So the y component of F sub g is equal to negative F sub g cosine alpha. Let's combine all these. Here's what we get. F normal minus Fg cosine alpha equals 0. In the next step, I'm going to isolate F normal, right? Because that's what we're trying to do. We're trying to come up with an expression for F normal so that we can eliminate it from the previous equation. So I'm going to isolate F normal. I will also substitute m times g for F sub g because that's the defining equation for F sub g. And here's what I get for F normal. F normal equals mg cosine alpha. Should I memorize this result? Absolutely not, because this result is specific to this problem. F normal is not necessarily always equal to mg cosine alpha. It just happens to be equal to mg cosine alpha in this particular problem. So what am I going to do next? Here's what I'm going to do. I'm going to take this whole thing, which is F normal, right? And substitute it right here. And rewrite this first equation. So that way I will eliminate F normal from my equation. Everything will be in terms of the given variables and acceleration. and I'm going to isolate acceleration. That'll be my final answer. So here I have substituted mg cosine alpha for f normal, and here's what I come up with. Now, is there anything that cancels? Yes, if you look at each term, every term has the variable m in it, so we can divide each term by m, so m's cancel. And alpha is A is basically isolated. All we need to do is to factor out the common variable g in the next step. So in the next step, I'm going to put A in on the left-hand side of my equation, and then factor out g from the remaining expression, and that'll be my final answer. And here's what I get when I do that. A equals g in parentheses sine alpha minus mu k cosine alpha. Also note that I have switched the order of the cosine alpha and sine alpha terms because I don't want to start with a negative sign inside the parentheses. It just looks nicer this way. So this is our final answer. Now let's do a quick sanity check or a dimension check. Do the dimensions match on either side of the equal sign? Is this answer dimensionally consistent? Meaning, we're looking for an acceleration. Is the expression that we're getting, is this also an acceleration, right? A is acceleration. Now, on the right-hand side, I have g, which is also an acceleration, right? Meters per second squared is the unit for g, so g is an acceleration. And it's being multiplied by that expression in parentheses. And the expression in parentheses has sine alpha in it. That's just a number. It doesn't have a unit. It's dimensionless. Minus mu k, another number, cosine alpha, another number. So that expression, that whole thing in parentheses is basically a dimensionless number. It doesn't have a unit, it doesn't have a dimension. So we have acceleration equals another acceleration times a number. In terms of physical dimensions, this is a consistent result. So that makes sense. It checks. That's what you should check when you're in your final answer in any problem like this, because this is a fairly complicated result. We need to know whether it makes sense or not. So one way to check that is to look at the dimensions of your result or the units of your results. See if the right hand side and the left hand side of the equation have matching units.